Now that we've learned how to convert radicals to rational exponents, we now have this situation where the exponent that we're dealing with is in a fractional form. In the past, you've learned how to deal with exponents of an integer nature, so x squared or x to the negative second power, which is 1 over x squared. And so you learned how to deal with these types of integer exponents and all the properties associated with those integer exponents. Now we're going to want to take those same properties and apply them to the rational exponents. And so we'll spend the rest of this lesson working on simplifying rational exponents based off of these properties, and also your ability to rewrite radicals as rational exponents. And then sometimes you'll need to rewrite rational exponents as radicals as well. So take a look at this concept summary box. We've given you some examples in here of the rational exponents being used with the properties, and all of this should look familiar from what you learned in a prior unit. So as we go forward into the next page here, we have 4 problems in sample 2, or excuse me, 5 problems in sample 2 for you to work. So go ahead and give each of these a chance. A couple of things that you might want to keep in mind here. A lot of times, whatever form the problem was given to you in, the most appropriate ending form would be the same thing. So if you're simplifying a rational exponent problem, you would want to end as a rational exponent. However, converting it to a radical is perfectly acceptable, and vice versa. So if you have one that is mixed, what you'll need to do is find which is the easiest way for you to approach the problem. So go ahead and try the 5 problems at this point in time, and then come back after you're finished and take a look at them. Okay, let's take a look at these. Some of these are more straightforward than others, so let's take a look at these first 3. In A, if you notice, we have a 5 and a 5. Since the bases of these two are the same, that means that we can add the given exponent. So I'm going to have 5 to the 1/2 plus the 1/4. And if you're not comfortable with fractions, you do have your calculator, which will help you do this. So make sure that you use that effectively. And so that's going to leave you 5 to the 3/4 power. Now, there's no need to change this to a radical. The only reason that you may want to change this to the radical is if you could simplify it further as a result of the radical. However, in this particular case, you can't go any farther. One of the easiest ways to tell also is to punch this into your calculator. If you get a decimal, then there's no need to go any farther. From a simplification standpoint, we want you to either leave it in exponent form or leave it in radical form, but we don't need you to put it in decimal form. Okay? Alright, so let's take a look at part B. In part B, we have a power of a power, so this negative 1/4 would be applied to both parts. So that's going to give you 2 to the negative 1 power and 3 to the negative 1 power. And of course, we want to make those positive exponents as soon as we can. So that's 2 to the first times 3 to the first, which gives us 1/6. Alright. C is a little tricky. C is a situation where you may work backwards in the problem. First thing I'm going to do is I'm going to distribute that power of 2. And of course, the way it's typed up is a little confusing. That's a power of 2 outside of this, and so I'm going to have 12 to the 2/3 power over 4 to the 2/3 power. Now, this is a situation where the bases aren't the same, but the exponents are. And so what I can actually do is I can reverse one of my properties here and pull that 2/3 exponent out. And so if you look at the way that's written, you could go backwards and forwards either direction. And now I can do the 12 divided by 4, which gives me 3 to the 2/3 power. And again, that doesn't simplify any farther. Alright, and so those are 3 basic simplification problems. Now we'll get to some that are a little bit more involved. D and E. So D is a situation where I probably could keep it in radical form, but a lot of times it's easier to convert it, and you're just going to have to get a feel for that. And so what I'm going to do first is I'm going to convert this to rational exponents. And then, of course, it's going to be much better for me to get these rational exponents if I can with the same denominator. Now, obviously, your calculator would be able to handle that, but it's always good practice. So notice we have the same base and we have division, so that means that I can subtract the exponent values, which gives me x to the 2/4, which we know is x to the 1/2. Now, this would be a perfectly acceptable answer. It was in radical form to start, so if you wanted to put it in radical form, you could also do that. You know that you should know at this point that any variable raised to the 1/2 power is also the square root of that particular one. Now E is quite a bit more involved. In E we have radicals and rational exponents, so whichever way you go, you would benefit from getting them all consistent. I'm going to do that by changing this to all rational exponents. So the square root of x is the same thing as x to the 1/2 power, and square root of y is the same thing as y to the 1/2 power, and of course this whole thing is being raised to the 2/3. Now I want to distribute the 2/3 here, so I'm going to have, and keep in mind, if I raise -8 to the 2/3 power, if you do not use the parentheses, you'll get the wrong sign in the end. So this is going to be x to the 2/3 times x to the 2/6 times y to the 2/6. And of course, you'll probably want to use your calculator for -8 to the 2/3. Make sure you use parentheses, and you'll notice that this actually equals 4. I'm going to reduce, go ahead and before I start to combine these, I'm going to go ahead and reduce the rational exponents so that I'm dealing with the same denominator. And of course you can see here we can combine the exponents with the x values, so that gives me 4x to the 3/3 when I add those together, so that's x to the 1st power, and then y to the 1/3 power. Now, that's a perfectly acceptable way to write your answer, or you could also write y to the 3rd root, and that is another way to write your answer. So you'll just have to get a feel for what you're most comfortable with there. I preferably, my personal point of view, I like them with rational exponents, but again, both are correct. Okay, well, so there's a good example of using properties of rational exponents.